Hello there, welcome to the channel. This video is the continuation of the topic about Spark execution flow, means Spark applications life cycle inside and outside Spark. In this video, we will discuss about Spark applications life cycle inside Spark, means we will discuss how Spark breaks Spark application to run into distributed manner. And doing so, we will discuss some of the important terms that are necessary to understand this topic. In my previous video, we discussed about Spark applications lifecycle outside Spark, where we discussed about the Spark driver, the executor, the cluster manager, the Spark master, and many more. I will give link of the video in description box in case if you are interested to watch that video. So before I start this topic, let me welcome you again. My name is Manna and you are watching the Spark series where we discuss about various Spark interview question topics. Please subscribe to my channel and share it with your friends. Thank you. So let's start. The very first thing that Spark looks into your application is a Spark session because it initializes the cluster. So your application must have a Spark session. The Spark session instance is the way Spark executes user-defined manipulations across the cluster. We use builder method to create a Spark session. It instantiates Spark and SQL context and avoids context conflict. Spark session allows you to access all APIs and legacy context and configurations. Spark session was introduced in Spark 2.x. Before that, we were using Spark context to access all these APIs and configurations. Please note that rarely we'll need to use Spark context now, but there will be some older code that might be directly creating Spark context. We will walk through Spark context now. Spark context is the object within a Spark session and it represents connection to the cluster. Using Spark context, we can access low-level API such as RDD and shared variables, that is broadcast variable and accumulators, and we can run the code on cluster. We can use Spark context using Spark session variable. Let me take this opportunity to make you understand the necessity of introducing Spark session when we already had Spark context in place. First thing is that earlier we were using SQL context and Hive context to access data frame and Spark SQL. Now with Spark session, we have centralized tool to access all these APIs. Spark session is more focused on high level tool like Spark SQL, whereas Spark context was more focused on fine-grained control over Spark. And second thing is that to use same Spark context per isolated environment. Prior to Spark 2.0, it was very expensive operation, as generally we can have one Spark context per JVM. Yes, we can create multiple Spark contexts by enabling spark.driver.allow multiple contexts to true, but this is very bad practice as it may make things very worst. It may make things very unstable. Now with Spark session, we can have various Spark session with same Spark context within same Spark application. I have a plan to make a separate video on Spark session, Spark context and Spark conf, so I will not go in much detail now, but with this explanation, definitely you can survive the question of what is the difference between Spark session and Spark context in interview. So now let's go and talk about our next topic. When you call an action in Spark application, it triggers a job. So normally there will be one Spark job per action. Each job breaks down into a series of stages and tasks. Number of stages depends on wider and narrow dependencies. Now let's go and talk about stages and tasks. Let's first discuss about a task. A task is a unit of work that can be run on a partition of a distributed data set and gets executed on a single executor. Each task is a combination of blocks of data and a set of transformations that runs on a single executor. If you have one partition in your data set, you will have one task. If you have 100 partitions, you will have 100 tasks. And those 100 tasks can be executed in parallel. So a task is just a unit of operation applied to a unit of data. And the unit of parallel execution is at the task level. All the tasks within a single stage can be executed parallel. So now I hope you understand what are tasks in Spark. Now let's go and talk about stages. Stages are a group of tasks that can be executed together to perform same operations on multiple machines. Spark will try to club as many tasks as possible into the same stage. If there is any shuffle, in that case, Spark starts new stages. Shuffle is physical repartitioning of data. Spark keeps a track of what order the stages run to get the final result. So this has given birth to another topic, that is shuffle. Shuffle is the process of redistributing data across partitions. Shuffle may or may not cause moving data across processes or network. By default, shuffle does not change the number of partition, but it changes content, and tasks within shuffle can be clubbed into a single stage. Soon I am going to publish another video to show you how to debug Spark application. There I will walk you through a sample code to show stages and tasks in more details. But with the kind of explanation we had just now, we can go ahead with current topic. Tasks and stages are very important internal parts of Spark execution flow. Spark execution flow has many features, but out of that, 2 features are very important and they are worth talking about. First feature is Spark pipelining. Spark automatically pipelines stages and tasks that can be performed together, such as a map followed by a map or followed by a filter. This is one of the key features because it makes Spark in-memory tool. Other one is that writing shuffle data. Spark for all shuffle operations such as repartition, join, co-group or any of the by or by key, Spark tries to write the data to stable storage, as for example on disk, and those data can be reused across multiple jobs. We will talk about pipelining and shuffle write in details now. Let's go and talk about pipelining. Spark tries to club as many steps as possible at one point before writing data to memory or disk. This makes Spark an in-memory computation tool, and it is very important feature of Spark. One such example could be a map followed by a map followed by a filter. In such cases, output of such operations can be fed directly to the next operation. This helps to reduce I/O cost, as we are not writing any intermediate result to a memory or disk. So it is very important feature of Spark that it can pipeline tasks, and with the help of that it can save lot of I/O cost. Now we will discuss our next Spark execution feature, that is a Spark shuffle write. Spark cannot perform pipelining on the operations where it has to move data across nodes, such as in case of any by or by key operations. In that case, Spark performs a cross network shuffle, and Spark, while executing such stages, first writes sending data to their local disk. Then the stage where grouping and reducing happens gets lodged, and within those stages, task fetch needed records from shuffle files. This is similar to user's own caching with cache method, where user control which data to save and where to save. Shuffle persistence lets Spark run the stage later than the source stage. It is helpful in case there are not enough executors to run both at the same time, and also it helps to start from the reduced task on failure and not to run all the input tasks. And other than this, if there is any other Spark job that uses already shuffle data, in that case Spark does not run pre-shuffle stage, so it helps in better performance. For this video, that's all folks. Thank you. Thanks a lot for watching my video. I hope I was able to make you understand Spark applications life cycle inside Spark. Please subscribe to my channel. Please like my video. Please give me suggestion, feedback and your comment in comment box. And if you want me to take any specific question, you can let me know in comment box, or you can send me email as well. Thanks a lot for your love and support. Keep loving, keep supporting. Thank you. Namaste.